Time to play the game!
Hello again. In this video, we'll talk about character strings. We've seen what a character was. So here's an example of main with a character C. I gave char C the ASCII value for star. So if I do a put char of char C, it should display an asterisk on screen. Compiling, launching, all good. In a previous video I made a mistake, remember? I used quotation marks instead of inverted commas. Quotation marks are for character strings. So, what's a character string? It's an ensemble of bytes, one byte next to the other. So a series of bytes each containing one character. And normally, the string's last element should be \0 or the value 0. The ASCII character for \0 or 0, they're all the same thing. Actually, for each ASCII character, there's a numerical value that defines the end of the string. How could we use this? It's simple. When you type 22, it'll be replaced by the address of first element of the character string 22, which is the address of T. Be careful. I just spoke about addresses. We're talking about pointers. You're probably telling yourself, okay, we're going to need a pointer. This time I'm going to call it *str. Now actually I'm going to call it *ptr. It'll be better. It's the same thing, we're still talking about pointers. I'm going to write something that the norm forbids. Actually, no, that'll just be confusing. So ptr equals to the address of the 22 character string. I told you a few seconds ago that 22 is a series of bytes, one after the other, that ends with a \0. And so when we write 22, the character string 22, we simply return the address of the first character. PTR can only contain an address. That's an important fact. From now on and for the rest of the video, we will talk about character strings. But remember, when we talk about a pointer to string, character string of course, in a way, it's still a pointer to char. It's a pointer to the first element of the character string. Let's just hope that in the end, when you go through your bytes, thanks to pointer arithmetics, all the way at the end you'll have a \0. That'll tell you to stop. But when you write this, the compiler will automatically set 22 in the memory. So char t, char 0, char t, char 0, and \0. And it will return the address of the first character, so t. Here's the proof. If I display *ptr, the element pointed by ptr, see, here's my t. Remember, I told you about another way to write this, which is easier, using square brackets. This should give me the exact same result. See, still t. So if I wanted to move around my string 22, the last element of the string, as we said earlier, when I told you to allocate 10 elements on the stack with an array, so the last element is the 9th element, exactly. So how many elements have I allocated for 22 truly? Nope, not 4. I'm sure everybody thought 4. It's 5. I told you earlier that there was an extra \0 at the end. So in reality I have 5 on the stack. But the \0 is something special, because it'll allow us to know when we're done browsing through memory, and that we're done reading the character string. So when you create character strings manually, you must remember to always end your string with a \0. Otherwise all programs that can read character strings will keep reading until they find a \0, and it could crash. Crashing is bad. So ptr square bracket, if I wanted to access the last O, ptr1 is the first O, ptr2 is the second T, ptr3, that's the last O. Let's display it. See? Cool, I've displayed the last O. If I try to display ptr4, as I've said, we have 5 elements on the stack. This is what happens. It doesn't display anything, sort of. Let's use the cat command on it. With the -e option, which displays non-printable characters. See those characters on screen? They represent \0, a simple character string. So I've successfully displayed the end of the 22 character string. Something very important you should know: when you write this, you've been given an address. But 22 is somewhere in memory when you're not allowed to write. Meaning that if I wanted to transform 22 into PO2, if I write this, normally it should either not compile at all or compile but crash. Bus error, I've crashed. Yay, that's exactly what I wanted to show you. 22 here is an area where we're not allowed to write. The only way for me to write over 22 would be to declare an array. But without setting its size, look at what I'm typing. Once you've done this, the compiler knows you're trying to allocate an array and that you want to write 22 in it. So it will allocate 5 elements, TOTO \0, and it'll put those 5 elements addresses on the stack. And PTR will be a pointer on that. So if I do the same thing, see, let's compile and execute. This time it worked. I have P as my string's first element. All of this seems fun for now, but I wanted to show you something to make things clearer. 30 seconds ago we had char star PTR. And underneath PTR equals 22. What happens if I add another char space star? Let's call it PTR2 and then write PTR2 equals lol. And then write PTR equals PTR2. What happens when I check PTR square bracket 0? Well, it's simple. If we follow the logic, PTR2 takes the address of I from L from lol, and PTR takes the address of 22 T. Now, when I write PTR equals PTR2, on the right I have a pointer to char, on the left I have a pointer to char. I'm allowed to write this. So what's PTR2? It's just an address. PTR is also an address, so I've overwritten the address contained in PTR by the address contained in PTR2. So the result is that PTR now points to the L, so normally if I execute this, I've displayed an L. So that's about everything you need to know about character strings. Just remember, a character string is a series of bytes, or characters, one after another, and that ends with a \0.